Imagine sending the most important secret in the world. A nuclear launch code, a trillion-dollar banking transaction, or a message that could change the course of history. Now imagine a lock so perfect that the moment someone tries to spy on it, the lock shatters and exposes the spy. Not metaphorically, physically. This is not science fiction. This is quantum cryptography. And scientists are already sending these unbreakable keys across real internet fiber cables. Tonight, we enter one of the strangest rabbit holes in modern physics, a world where the universe itself becomes your security guard. The ancient war of secrets. Human civilization has always been a game of secrets versus spies. In ancient Sparta, messages were wrapped around a wooden rod called a scytale. In medieval Europe, kings used cipher alphabets. During World War II, the Nazis trusted a machine called Enigma. They believed it was impossible to crack, until a quiet mathematician named Alan Turing helped break it. That moment shortened the war by an estimated 2 years and saved millions of lives. History lesson number 1. Every code humans create, other humans eventually break. It's an arms race. Stronger locks, smarter thieves. But then physics entered the fight, and physics doesn't negotiate. Why normal encryption is actually fragile. When you send a message online today, banking, WhatsApp, military data, it's protected by mathematical encryption. The most famous system relies on something called prime factorization. Take a huge number, multiply 2 secret primes together. The result becomes your lock. Anyone can see the lock number, but figuring out the 2 primes that made it, that's astronomically hard. Even supercomputers struggle. But there's a looming monster on the horizon: quantum computers. A sufficiently powerful quantum computer could run Shor's algorithm and factor those numbers dramatically faster, meaning one day many of today's encryption systems could collapse. Banks, governments, satellites, everything. So scientists asked a radical question. What if security didn't depend on math being hard? What if it depended on physics being impossible to cheat? The weird law that changes everything. Quantum physics contains a bizarre rule. You cannot measure a quantum system without disturbing it. This is related to the Heisenberg uncertainty principle, but in cryptography it has a profound implication. If a spy tries to observe a quantum signal, they leave fingerprints. Imagine sending information not with electrical pulses, but with single particles of light, photons. Each photon can be polarized in different directions: vertical, horizontal, diagonal. Those orientations represent bits of information. But here's the trick. If an eavesdropper tries to intercept the photon to read it, the measurement changes the photon's state, and the receiver immediately detects the tampering. It's like sending a letter where the envelope explodes if someone opens it. Nature itself becomes the security system. The birth of quantum key distribution. In 1984, 2 scientists had a wild idea. Charles Bennett and Gilles Brassard proposed something called BB84, the first quantum key distribution protocol. Instead of sending secret messages directly, you send the key that will later encrypt the messages, using photons. Here's the simplified version. Alice sends photons to Bob through fiber optics. Each photon is randomly polarized. Bob measures them using random detectors. Later, they compare notes publicly. If too many photons were disturbed, they know a spy was listening. Key discarded. Start over. If not, they now share a perfectly secret key, and no one, not hackers, not governments, even quantum computers can reconstruct it, because the moment anyone tried, the physics would reveal them. This isn't theory anymore. Here's where the story stops sounding like a physics lecture and starts sounding like a spy movie. Quantum cryptography is already being tested across real telecom infrastructure. Banks in Europe have experimented with quantum-secured communication lines. Scientists have sent quantum keys across hundreds of kilometers of fiber optic cable. Even more dramatic, in 2016, China launched a satellite called Metis, dedicated to quantum communication. It demonstrated quantum key distribution between space and Earth, meaning one day we may have a planet-wide quantum internet, a network where eavesdropping becomes physically impossible without detection. Financial institutions are watching closely because in a world of trillion-dollar cyber attacks, security is priceless. The limits no one talks about. But before we crown quantum cryptography king, let's stay honest. There are limitations. Photon signals weaken with distance. Fiber optics absorb light. Most current systems work over hundreds of kilometers, not thousands. Repeaters are difficult because quantum states cannot be copied, another strange law called the no-cloning theorem. Engineers are working on quantum repeaters to extend range, but for now, quantum cryptography is powerful yet still evolving. Technology rarely arrives fully formed, it grows. The philosophical twist. Here's the part that makes physicists pause. For thousands of years, we believed security depended on secrets hidden in human minds. Now, security can depend on the structure of reality itself. The universe is telling us something strange. Observation changes reality. Information is physical, and the act of spying is no longer invisible. In quantum cryptography, the universe itself tattles on the spy. If Shakespeare wrote about cybersecurity, this would be the plot twist. Think about what just happened. For most of history, spies tried to become invisible. Now, physics says you can look, but you cannot look without leaving footprints. Quantum cryptography turns the laws of nature into a security protocol. And the deeper we explore quantum mechanics, the more it seems reality itself behaves like information. Which raises a bigger question. If the universe runs on information, who wrote the code? If you want the next episode, we're diving even deeper into a mind-bending topic, the quantum internet. The future network could teleport information itself. Subscribe because the rabbit hole only gets deeper. And trust me, we've barely scratched the surface.